Hello all, welcome to Excel Academy. So today we are going to study on the topic that is your open loop and closed loop control system, right? Just a minute. So open loop and closed loop control systems are of very important for your examinations, right? So the types of control system is this. There are many, but main important thing is open loop control system as well as closed loop control system, right? So that is what is you have to study, right? So now let us come to first open loop control system. So we are going to learn about what? We are going to learn about this open loop control system. So what is an open loop control system? So if you define an open loop control system, definition, if you define an open loop control system, so just a minute guys, I'm sorry. Yes, if you see the definition of open loop control system, so you can see that, so what is the definition? So my definition states that a system in which a system in which an output is dependent upon the input, right? A system in which the output is dependent on input. I can write output as this, right? You understand, right? Yes, output is dependent on, just a minute guys, yes, output is dependent on input. But your control input, or what I can say, but your input is not dependent upon output. I can say the controlling action, or I can say the input is not dependent upon the output, right? Yes, or not dependent, I can say totally it's independent, right? I'll write the definition guys and showcase to you in a clear manner. Just a minute, give me a minute guys. Yes, so now let me start it guys. So yes, it's here. So my open loop control system definition states that a system in which, I'm sorry, can you see? I'll hold it like this. Can you see? Yes. A system in which output is dependent on input, right? Your output, whatever you get from the system, that is depending upon the input, but the controlling action or input is totally independent on the output or the changes in output of the system, right? What does this mean? This directly means that your output is depending upon the input. What I can say, output is depending upon input, but your input is completely independent on your output, or that is the changes in output. That is what I tell it as what my open loop system definition, right? It's just a simple one. I guess you can understand. Here your input is not totally independent from the output or the changes in output that is going to happen, and you can see that. So there is a what I can say, but your output is dependent upon input, right? How output is dependent upon input here is because whatever the input you provide, depending on that the output will get generated, right? It is obvious, it's a natural process that when you give input to any of the device, so based upon the input only you're going to get the output, right? So that is what is one agenda. So that is why output always depends upon input, but your input will not depend upon output, right? Yes, your input will not depend upon output. Input is the one that you give, right? That you give, right? That you give, but it is not dependent upon the output. So output and input and output are not connected to each other, but your output and input are connected to each other. So the changes, whatever you give the input to the device, so that changes that happens in the device and the output that is produced, it is whole totally depending upon input. When you apply input only, you get the output. So therefore output and input are interconnected to each other, but input and output are not connected to each other, right? Your input is separate and output is separate there, but your output and input are connected to each other. The pair is like output and input pair, not input and output pair, right? Yes, understand, right? You understood, right? Yes. Your input is separate, it's independent. You just give an input. But what is output? Output is the changes in input that occurs when you provide an input to the system. That yesterday we studied, right? Yes. When you give any input to the system, the changes in the system that happens and the resultant that you get is what I call it as an output. So therefore, output is whole and sole dependent upon input, but your input is not dependent upon output because the input is the one that you give, right? Yes. So now let me come to, yes. So now let me come to the block diagram of control system. I mean open loop control system. So see here we are going to learn three things, guys. Four things. One is one is the definition of open loop control system. That is the block diagram of what I can say the open loop control system. One is the block diagram of open loop control system. And then you'll study about the advantage as well as the disadvantage, right? Yes. So now let me start with the block diagram. So my block diagram is stating that this is my reference input R of t. So what is my reference input? Just a minute, I'll write it here. So what is my reference input? So I've already discussed with respect to the reference input, right? Just a minute. A reference input we have already studied. So what is reference input? So that is reference input and controlled output. I told you about that while teaching with respect to the what I can say the components of control system. That is the plant or process, the controller, the input output, the disturbance, and I told that we call our input as reference input and we call our output as the controlled output, right? That is what. So let me write it in a shorter manner. I need to write things in one go. That is why this is reference input. So reference input is what I call it as R of t. So this R of t, what I can say, I'll give it to the controller. I'll give it to the controller and then this is what is my U and here is what is my process. So I'm just writing the diagram, guys. Please do pardon me. I'm just writing the diagram and here we are supposed to what I can say understand the concept. I'll teach you now, right? Just you have to write it here as what? You have to write it here as that is controlled output. Just a minute, guys. You got the diagram? Yes. So what is controlled output is what I call it as C of t, right? Yes. So see here, this is what is the particular. So you have a reference input R of t. You have a controller, so that is given to the controller and this controller generates U and this is the process and this is controlled output, that is C of t. You got it, right? Yes. So now let's learn one by one. So what is a reference input R of t? I told you that your input and output can be described as the reference input R of t and what I can say the controlled output C of t, right? So now you are going to give the reference input R of t to the controller first. So let's understand things well. So here you apply reference input R of t to the controller. So just you can write it as R of t. I guess you understand this is what you're going to write. That is R of t to the controller, right? You apply it to the controller. It is controller. So what you do, so just a minute, yes. So you apply reference input R of t. So this is reference input R of t, you apply to the controller and then next what is that going to happen is you are going to, what I can say, you are going to get the actuating signal, that is U. So where is U? U is here. Can you see? So U is here. Just a minute, guys. Yeah. So your U is here. This is actuating what I can say the signal, right? This is actuating signal U. So what is actuating signal U? So actuating signal U is the one which will control the process which is to be controlled, right? I told you what is the plant torque process. So what is the plant torque process? Plant torque process is the part of a system wherein you have to control that particular, right? It's a part of the system which is to be controlled or regulated, right? It is controlled or regulated by using a controller, right? Yes. So here you are going to write, it generates an actuating signal U. Just a minute. Yes, actuating signal U. Actuating signal U, which is going to control the process which is to be controlled, right? Yes. So please to understand, I'm sorry, please to understand the concepts well clearly. Yes. So the understanding the concept is, I'm sorry, really important factor, right? And if you don't understand the concepts well, then it would be really difficult for you to crack your examinations also, right? The way you understand, the way you reproduce in the exam, that is what is that going to happen, right? For example, in any of the problem also, the way you understand, so the way you reproduce in the exam and whatever you have understood, that is what reflects in your paper, right? Yes. So before that, I forgot to tell you yesterday one thing. I was always repeating you the same thing. So basic signal processing question paper is reviewed. So please do check. If anybody is new to the channel, please do check that so that you get to know what is inside our channel, right? How is the channel working on, right? So we are working on in respect to exam questions, and whatever the questions we have told that it would come for an exam, it has come for the exams, and I've done problems on that also. So the same process you're supposed to follow, right? I told you that you would get a question from discrete signal. So the same thing you got it. Yes, so that is fine. So we'll first check with respect to examination. So which is coming for the exam, which is really important for exam. Then we start practicing it, right? It is not that we do everything blindly. Blind doing is not my motto. And I check first for the examination which is going to come, and then for that only I'm going to start teaching that, right? So this is what is an actuating signal U. So this signal U will control the process, so which is to be controlled. So you have a process over here, right? Just a second. You have a process, I'm sorry, hold it clearly. So this is a process over here. So this process will be controlled by using this actuating signal U, right? Yes. So when you apply the reference input R of t to the controller, so what does the control will produce? The controller, this controller will produce an actuating signal, that is U. So that U will, what I can say, it will control the process, right? It will control the process that is to be controlled, and that will provide the controlled output C of t, right? What does the process do? The process will, what does the process do? The process will produce the desired control output, that is C of t, right? Necessary desired, whatever you require, that is it is going to provide, right? The process is giving out controlled out, giving ing jving, okay, giving out the controlled and giving out the C of t. C of t is what is called as my controlled output, right? Yes, so now we understood what you understood with respect to the particular open loop system, that is open loop control system definition. What it is telling? It is telling that here you can see a system in which the output is dependent upon input. So your output is depending upon the input, but your controlling action or input is totally independent on the output, right? Or the changes in output system, right? So like you can easily understand, he is telling you that the changes in output system, he is telling what is changes in output system. So if any change takes place in output, it is not affecting the input, because input is the one that you give, right? But output will get, but if there is any changes on input, your output will get affected, right? So whatever the input you give, based on that only you get the output. That is, whatever the input you give to a device, so that device will work on that particular input and it will give the output, right? So output and input are interconnected, but your input and output are independent here, right? Independent here, right? Yes. So that is what it's called as a open loop control system. And we learned about the block diagram of open loop control system. So this is, I told you right now, this is reference input R of T. If you give it to the controller, so it will give an actuating signal U. So that U will control this whole process, whatever I've written here, and it will provide the controlled output C of T, right? So now let me come to the, what I can say, the advantage and disadvantage of open loop system, right? So see, in the case of open loop and closed loop control system, you get a question on comparison process, right? You get a question on, that is, comparison between open and closed loop, right? Yes. So what is my agenda here is, so I just thought of teaching open loop and closed loop separately, so that you can understand clearly, right? You can understand clearly. If I club it together, it becomes a very long. So please do make sure that you study it in a separate manner, right? So now let me come to the advantage and disadvantage of open loop control system. Just a minute. Yes, so now if I come to the advantages of open loop control system, so there are some advantages and disadvantages too, right? By the disadvantages, you get to know a conclusion. So first, let us learn the advantage. So its advantages are, my very first advantage is, they are simple in construction, right? So what is simple in construction? So many people likes this, right? Why? Because if you are constructing any device, or if you are constructing any of the machinery, so you will first have an idea of construction, right? That is with respect to the process of construction, right? Here it is simple in construction. What does that mean is, there is no complexion in construction. You can easily construct it easily without fail, and you don't have any hurdles during construction, right? That is what is the one thing you all like and you all require it, one who designs device also. Now, very much convenient when output is difficult to measure. So it is much convenient, right? It is much convenient when you have a difficulty, convenient when output is difficult to measure. I'm sorry. If your output is difficult to measure, it is very much convenient, right? Just a minute, guys. Yes. Just a minute, guys. So it is very much convenient when your output is difficult to measure. So that is what we call it as the second advantage of what I can say, the open loop control system. What is a convenient, suitable or practical for a particular purpose? That is, it's suitable for the particular time. So when you have a difficulty in measuring your output, so this open loop system is really suitable for that particular. That means your output can be easily measured without fail, right? So now coming on to the third one. So just a minute, guys. So I'll write it, the third one here itself. So what is my third advantages? So there are many, there are 5 advantages. You can write any 2 to 3 advantages without fail. And such systems are easy maintenance, right? So easy maintenance from point of view. What is easy maintenance, guys? You know, right? If you plan to buy any device at home, right? If you plan to buy any device at home, so what do you feel? So you might check in a device where it's easy to maintain, right? If anybody says that this device is really difficult to maintain for you, then what I can say, then how do you feel? Do you buy that? No, right? You don't buy that. You say that it's difficult to maintain, and you have to for more cost. It will take more cost for the maintenance, and you don't even buy that, right? So that is what is the same thing here. So easy maintenance is one of the important point here, wherein open loop system can be easily maintained, open loop system can be easily constructed, and open loop system can be what? Open loop systems are, that is convenient when the time wherein you can't measure the output. So that is, your output is difficult to measure, right? So now let me come to the point number 4. Just a minute, guys. Yes, guys, so let me just write my point number 4. So what is my point number 4 with respect to the open loop control system advantages? These are not troubled with the problem of stability. You can directly write problem of stability is eradicated here. Yes, problem of stability is eradicated, right? So there is no problem of stability over here, eradicated, right? Yes. So my point number 5. So what is my point number 5? So my point number 5 will state that, so it is such systems are simple to design and hence economical, right? Design process is also simple, right? So very first point is telling that it is simple in construction. So right, its construction is simple, so you need not to work on, what I can say, the complex constructions, and it is design. So whatever the design with respect to open loop system is also simple. So just a minute, simple in design and hence they are economical, right? So all these points are really important. How? So well, the points in the case of 5 points, I'll tell you, just a minute. So it is economical, right? Yes. So see, what I'm trying to tell is, in this 5 points, the point number 3 and point number 3 is really important for us, right? We also expect point number 3 always, right? And point number 1, 2, 4 and 5 is that the one who develop a machinery or who develop a device will accept, right? Will expect, right? He'll expect all these things. So this is what is the one. But this is some of the advantages, but there are some disadvantages. So that disadvantages will yield you to a problem, right? Yes. Let us learn what is those disadvantages. So coming on to the disadvantages, so let me write disadvantages. Yes. So if I come to the disadvantages, so very first thing, what is that one is, so you can see that such systems are inaccurate and unreliable, right? Inaccurate and unreliable. What is inaccurate? Your accuracy should be proper, right? So what is inaccurate in the sense, like you have some value to be got, right? Like for example, you have to get some 1 kilohertz there, but if you are getting 2 kilohertz in the place of 1 kilohertz, you can say that it is inaccurate, right? Why it is inaccurate and unreliable? It's inaccurate and unreliable because its accuracy, of such system is depending upon the accurate recalibration of the controller. Just a minute, I'll write. So because the accuracy of such system is missing. Accuracy of such system yes, accuracy of such system is depending upon the what I can say, accurate recalibration of the controller, right? Yes, just a minute, I'll write. Yes. right? So you got it right. Why it is? Because so what is pre-calibration? Pre-calibration in the sense you're going to, what is a calibration, guys? Calibration in the sense you're going to compare the, what I can say, the values that you got in a device under the test along with the accurate values of that particular, right? For example, if you're giving a device for a test, so whatever the values that you get from the device, so you are going to check with the accurate value of that particular device, or it's just a comparison of the accurate value to the whatever value we have got, and that is what is calibration. And you have to always pre-calibrate the controller, right? You have to do the pre-calibrate the controller, and so therefore this accuracy will depend upon the pre-calibration of controller, right? It is inaccuracy and unreliability. Inaccuracy in the sense the values are not that accurate that you get, right? You don't get accurate values, right? For example, when you check with a weighing machine, or when you check with any a BB machine at home, so whatever you get it from a doctor, sometimes it might vary with respect to that particular machine that you use it at home, right? So it must be accurate, correct, accurate value, right? You might find some inaccuracy in your calculators also sometimes, right? Yes. So why it is inaccurate and unreliable is because this system's accuracy is depending upon pre-calibration of controller. That is, when you pre-calibrate on it will provide the accurate values, or else it will not, right? It will check that the control is pre-calibrated. If it is not, it will produce a, what I can say, the wrong output, right? Yes. So now second one is, they give inaccurate results if there are variations in external environment, right? What I can say, why if there are variations in external environment. So what does this means? So this means that we learned it is providing inaccurate values. Why it is? Because the accuracy is depending upon the accurate pre-calibration of the controller, right? But here it is, if there are variations in, here is telling one more reason, that if there are variations in environmental changes. So like this device will have, this device is simple to design. What I can say, it is simple to construct, it is easy to maintain, and it does not have any problem of stability. And when you have difficulty to find the output, so this device can be used. But what is the disadvantage here is, if there is any changes in environment, or if there is any variation happening in environment, or if there is any internal disturbances in the system, it does not sense it, right? Yes. So that is why it provides inaccurate value. So it is not a matter of construction, guys. It is not a matter of construction, or it is not a matter of simple design, or it is not a matter of easy to finding the output. So when you what I can say, device, so what I can say, when you design a device or when you invent a device, so the main thing that you have to see is your output, right? It should be, the output should be your accurate output, right? If your output is inaccurate, if any disturbance that is going to happen outside or inside the device, if it is not going to, what I can say, sense it, so then it is really a that device is not of that sense, right? It doesn't make that sense, right? Whether if it is simple to design or simple to construct, or what I can say, it is easy to maintain, we don't want that. We want the proper output, right? If there is no proper output, then how can you use a device? It is not at all possible. We also will not accept that device, right? Yes. So this is what is the second and the third point that I told you. And the fourth one is, fourth one is what? So fourth one is what? You have to recalibrate the controller, right? Yes. Recalibrate in the sense you are going to always check with the values, compare the values of the controller with the controller, whatever you get with the accurate values of that particular, right? So that is what is recalibrate. So you always have to recalibrate the controller without fail. So to get the accuracy and reliability, right? If you what I can say, this is something of not that sense, because if your device is satisfying everything, but it is not providing accurate output, and you have another work to do. What is that? You have to always recalibrate the controller, right? If you always recalibrate the controller, how many times can you recalibrate the controller, right? It's telling recalibration of controller is necessary to get accurate and reliable values time to time, right? So time to time you can't do, right? You can't do that. You can't go again and recalibrate the controller, and you can't go again and recalibrate the controller. How many times will you recalibrate? It is the waste of time recalibrating the controller, right? So that is why, to overcome all this, just a minute, I'll write reliability, that is time to time. So this is what is the disadvantage. What is the disadvantage? The very first disadvantage is it doesn't provide, okay, I'll just go back. Yes. So it will not provide what? I'm sorry, here it will provide inaccurate and unreliable values. Why? Because this accuracy is depending upon the pre-calibration of controller. So pre-calibration of controller in the sense you have to calibrate the controller from time to time. That is what here we have studied in the last point. That is, recalibration of controller from time to time is required to get the accurate and reliable values, right? And here it is, if it will provide inaccurate values when if there are variations in the environment or if there is any internal disturbance. So what does this mean is that it will not go through, like it will not see the internal variations in the environment, or it will not see through the internal disturbance. That means that it will not get to know all this. It will not get to know the variations in environment that is happening if there is any variations, or it will not get to know any internal disturbance that is going to happen, right? So that is why if it doesn't get to know, then it will provide inaccurate values. If it at least senses that, so you can get a proper value, right? But it is not sensing that only, right? And here I told you that you have to recalibrate the controller, that I told you already. So to overcome all these things, so to overcome all this disadvantage, so accurate value is the very important thing, and as it is not providing that, to overcome all this, we make use of one system which I call it as, that is closed loop control system, right? So that one we are going to study next class, and please do like, share and subscribe, and please do understand the please do watch our videos, and please do understand the concepts clearly well, and please do if you have any doubts, or if you are not understanding any of the parts, or if you need still more good teaching, you can just text me out in the comment section. I'm happy to take all the comments that you give, and I'm going to do my best to improvise you students, and thank you.